We know that real numbers consist of both rational and irrational numbers. We have learned how to add, subtract, multiply, and divide rational numbers. Adding, subtracting, multiplying, or dividing two rational numbers always gives a rational number. Let's now see how to add, subtract, multiply, and divide irrational numbers. Let's also find out whether the result obtained by adding, subtracting, multiplying, or dividing two irrational numbers will always be an irrational number, as in the case of rational numbers. In addition, we will find whether we can convert an irrational number to a rational number. And finally, we will explore the concept of rationalization, which is the process of making the numerator or the denominator rational. First, let's see how to add two irrational numbers. For example, square root of 2 plus square root of 2 is 2 times square root of 2. And square root of 3 plus 4 times square root of 3 is equal to 5 times square root of 3. Now, are the results 2 root 2 and 5 root 3 irrational numbers? Since the square root of 2 and square root of 3 are irrational numbers, 2 root 2 and 5 root 3 are also irrational numbers. Square root of 2 plus negative square root of 2 give the result 0, which is a rational number. Thus, we can say that the sum of two irrational numbers may or may not be an irrational number. Similarly, the difference between two irrational numbers may not always be an irrational number. Next, let's check the sum of a rational number and an irrational number. Since square root of 2 is a non-terminating and non-recurring decimal number, 3 plus square root of 2 is also a non-terminating and non-recurring decimal number, and hence it is also an irrational number. Similarly, let's check another example. Pi minus 3 is also an irrational number. Therefore, we can say that the sum or difference of a rational and an irrational number is always an irrational number. Now, add or subtract the given irrational number. Now, let's see the product of two irrational numbers. As you can see, the product of an irrational number with itself may not be an irrational number. Therefore, we can say that the product of irrational numbers may not always be an irrational number. Next, let's see the division of two irrational numbers. As you can see, the division of irrational numbers may or may not be an irrational number. Therefore, we can say that the division of irrational numbers may not always be an irrational number. Now, let's take a rational number and an irrational number. The product or quotient of a non-zero rational number with an irrational number is always an irrational number. We are familiar with the algebraic identities for a plus b whole squared, a minus b whole squared, and a minus b into a plus b. Similarly, we have some identities in irrational numbers too. Let's explore them. The product of square root of a and square root of b is equal to square root of a times b. Here are a few examples. Notice that the result after multiplying two irrational numbers may be a rational number or an irrational number. Next, the square root of a over the square root of b is equal to the square root of a over b. Here are a few examples. Notice that the result may be a rational number or an irrational number. Next, using the algebraic identity x plus y into x minus y equals x squared minus y squared, we can deduce an identity similar to this for irrational numbers. The product of the square root of a plus the square root of b and the square root of a minus the square root of b is equal to a minus b. Here are a few examples. Notice that the result is always a rational number. Similarly, the product of a plus square root of b and a minus the square root of b is equal to a squared minus b. Here are a few examples. Notice that the result is always a rational number. Next, let's look at another identity. The product of the square root of a plus the square root of b and the square root of c plus the square root of d is equal to square root of ac plus square root of ad plus square root of bc plus square root of bd. Here is an example. Finally, using the algebraic identities x plus y whole squared and x minus y whole squared, we can write the similar identities for irrational numbers. The square root of a plus the square root of b whole squared is equal to a plus 2 root ab plus b. And the square root of a minus square root of b whole squared is equal to a minus 2 root ab plus b. Here are a few examples. Notice that the results may be a rational number or an irrational number. We can represent irrational numbers such as square root of 2, square root of 3, and square root of 5, etc. on the number line using Pythagoras' theorem. But how do you represent irrational numbers in which the denominator is irrational, such as 1 over square root of 2 and 1 over square root of 8 on the number line? Well, we can make the denominators of such numbers rational by multiplying and dividing them by a suitable irrational number, and hence we can represent them on the number line. The process of making the denominator a rational number is known as rationalization of the denominator. And the number by which the irrational number is multiplied to make it rational is called the rationalizing factor. For the irrational numbers root 2 and root 8, the rationalizing factor is root 2. Now, what is the rationalizing factor for rationalizing the denominator of these numbers? Recall the identity a plus square root of b into a minus square root of b is equal to a squared minus b, which is a rational number. So, the rationalizing factor for the irrational numbers of the form a plus root b is a minus root b, which is known as its conjugate. Let's rationalize the denominator of 1 over 5 plus root 2. Remember the product of a plus square root of b and a minus square root of b is a rational number. Multiply the numerator and the denominator with 5 minus square root of 2 and then simplify. Thus, we get a rational number in the denominator. Let's look at another example. To rationalize the denominator of 3 over 2 minus 3 root 5, multiply the numerator and the denominator with 2 plus 3 root 5 and then simplify. Thus, we get a rational number in the denominator. Rationalize the denominator of the given irrational number. Multiply and divide by the rationalizing factor of the denominator and simplify. If a is equal to 2 minus square root of 3, what is the value of a squared plus 1 over a squared? First, find 1 over a and express it with a rational denominator by rationalizing the denominator. Now find a plus 1 over a. Use the identity a plus b whole squared to find the value of a squared plus 1 over a squared. Of x in the given equation. First, we rationalize the denominator of the left-hand side of the equation. Next, we compare the result with the right-hand side value. Thus, we find the value of x.